Learn it fast, learn it smart, learn with us at SOFO. Subscribe now for more videos. Contact us for on-demand and regular tuition classes.
Welcome to Concept Videos from SOFO Learning. In this video, we are going to take a closer look at the relationship between zeros and coefficients in a polynomial. But first, let us do a small recap of what we learned from previous stages, previous videos. Namely, the zero of a polynomial is the point where the polynomial p of x is equal to 0. It doesn't represent the point where x is equal to 0. Now, we're going to start by looking at the standard form of a quadratic equation, which is ax squared plus bx plus c equal to 0. Now, you can see that we have a square term of the variable p of x, and therefore you have degree 2 for this equation. The degree of this equation is degree equal to 2, and therefore it is a quadratic equation. Now let's say that alpha and beta, the zeros of this equation, are alpha and beta. Let's imagine this p of x using these alpha and beta variables. So it would essentially look like this: k, which is a constant, times x plus alpha times x plus beta, all equal to 0. Now, this is the original p of x using the variable x in there, and this is the same p of x polynomial, but it contains the variable x and our imagined zeros being alpha and beta. Now, what we want to do is let's expand this equation further, where if you do this at home, you're going to get k times x squared plus k times alpha plus beta of x plus k alpha beta equal to 0, right? Now, what we are trying to do here, let's use a different color now. What we are trying to do here is we are trying to find similarities between these three terms from the original equation. So you have kx squared here and you have ax squared. What does that mean? It means a equal to k. Now, you can see the similarity between these two terms, and therefore b is equal to k times alpha plus beta, and c is equal to k alpha beta over here. K alpha beta over here. Now, what this clearly demonstrates is that there is a relationship between the coefficients a, b, and c and alpha, beta, which are the zeros of this equation. All right, now we're going to show this further. We're going to evaluate this further, study this further using a specific example. The example equation that we want to try this theory with is 2x squared plus 9x plus 10 equal to 0. Now, according to our theory, we have alpha plus beta is equal to negative b by a, which is 9 by 2, and alpha beta is 10 by 2, which is 5. Now, our next step is to basically solve this equation. So to solve the equation, we need to imagine a p and a q. Let's say p plus q is equal to this 9, and p times q is equal to this 10 times 2, or 20. So we know that p would be 5 and q would be 4. Multiplied you get 20 and added you get 9. So let's redo this equation. You get 2x squared plus, let's say, 4x plus 5x plus 10 equal to 0. All right, now if you, for this portion, you can take out 2x, so you get 2x times x plus 2, plus if you take out 5 for this portion, you're going to get x plus 2 equal to 0. Now x plus 2 and x plus 2 is common, so you get x plus 2 and 2x plus 5 equal to 0. All right, now what are the roots of this equation? What would be the alpha and beta? You can see it from here. All right, so if you take x plus 2 equal to 0, you're going to get the value of x or the alpha equal to minus 2, and if you take 2x plus 5 equal to 0, you are going to get beta equal to minus 5 by 2. All right, now if we multiply these two, alpha beta, let's see what we get. Alpha beta is minus 5 by 2 multiplied by minus 2 is equal to 5. So the same value here. And if we do alpha plus beta, what we're going to get is minus 2 plus minus 5 by 2, and this is negative 4 by 2 plus negative 5 by 2, or you are getting negative 9 by 2, the same value as here. All right, so we have now proven that theory. So the relationship between the coefficients, let's recap just one more time so we are clear. The relationship between the zeros and coefficients is right here. The sum of the zeros, alpha plus beta, is negative b by a, b being the coefficient of x, a being the coefficient of x squared in a quadratic standard form, and alpha beta, the product of the zeros, is c by a. C is the constant term and a is the coefficient of the x squared term in a standard quadratic polynomial. We can apply the same principle to a cubic polynomial. So the standard form of a cubic polynomial p of x would be ax cubed. Cubic means degree 3, and that's why we have a cubed term of the variable x. So ax cubed plus bx squared plus cx plus d. All right, now as you remember, right, there are three maximum possible zeros for this polynomial, and therefore let's imagine three zeros, which is alpha, beta and gamma. All right, these three to be here. Now in the same way as before, what we need to imagine is a slightly different form using these three zeros. So you get p of x is equal to k, which is the constant term, times x plus alpha, I corrected it, x plus alpha times x plus beta times x plus gamma. All right, now I would urge you to do this at home, but you will get a pretty lengthy equation if you expand this, which I will write it down over here now. This is the expanded form, kx cubed minus k plus k times the sum of all the zeros, alpha plus beta plus gamma, which forms the coefficient of x squared. Remember, that is b. Coefficient of x is a, so a is equal to this k, b is equal to this term right here. And now let's look at c, which is alpha beta plus beta gamma plus alpha gamma. So taken two at a time, you multiply the zeros and you add together. you're going to get the C variable, and if you were to multiply all the terms nk, alpha, beta, gamma times k, you're going to get D. Thank you for watching.